Okay, you know what it's time for? These are the answers. You should already have checked them, but here they are briefly. Those are all the non-graphing problems. Pause it if you need to. Just check your answers. Degree symbols for answers and degrees. Lack of a unit for angle implies radians. The last three problems, graphs, would look like this. You should have all that stuff on your graphs. So, okay, let's try and use memorized values here. You shouldn't be converting radians to degrees. You got to get away from that. The best way to get away from that is to force yourself to deal with radians. So the common angles to radians are 0, pi over 6, pi over 4, pi over 3, pi over 2. And the bigger the denominator, the smaller the angle. The smaller the denominator, the bigger the angle. So 6, 4, 3, 2. So for tangent, it's going to be sine over cosine. And sine and cosine have the same values, but cosine is backwards, sine. So, say 0, pi over 6, pi over 4, pi over 3. That's the further angle, 0, 1/2, root 2 over 2, root 3 over 2. Cosine is going to be 1, root 3 over 2, root 2 over 2, 1/2. And you're going to get root 3 for your answer. There you go. And alpha was pi over 3 here, and it was quadrant 1. So here, 11 pi over 6, that's almost 12 pi over 6. That's almost 2 pi. That's almost whole circle. Alpha is pi over 6 left to get to. This is alpha, right? And this is 11 pi over 6, almost whole circle. So this is alpha. It forms that right triangle to the horizontal axis. It is quadrant 4. Cosecant is 1 over sine. And so we're going to do sine of pi over 6, 0, pi over 6, that first angle, 1/2. It's going to be negative in quadrant 4, so your answer is going to be -2. Okay, negative 4 pi over 3 would be, this is negative 3 pi over 3. Negative 4 pi over 3 is going to be here. And alpha is going to be right here. So alpha equals pi over 3. You're in quadrant 2. Got there backwards. So sine of pi over 3, 0, pi over 6, pi over 4, pi over 3 is that further angle. 0, 1/2, root 2 over 2, root 3 over 2. It's in quadrant 2, so it's positive. And that's it. So you should be able to do this quick and easy. Work in radians. Don't change the degrees. Now these are going to be in degrees. Okay, the next ones will be in radians. You should be able to switch back and forth. Shouldn't have to go from one to the other, like translating. So we're going to isolate the trig, subtract 1, divide by 2. We're going to identify alpha, ignore the negative. 1 to sine equal 1/2, 0, 1/2. That's that first angle, 30 degrees. It's negative in quadrants 3 and 4. So you usually get multiple answers when you solve trig equations. There's multiple quadrants where those values happen. So quadrant 3 would be 180 plus alpha, 210 plus 360k. And quadrant 4 would be 360 minus alpha, 330 plus 360k. So all the answers from 0 to 360 are going to be 210 and 330. Now I just make a habit of doing the infinite expressions, because like on the next problem, the next one, it's going to make a big difference. So I just do it all the time. Cotangent is 1 over tangent. Tangent sine over cosine, so it's going to be cosine over sine. So I always change everything to sine and cosine. Now, you got to think, okay, well, this is over 1. Maybe we could make them both over 1/2. That would have gone away. So we're trying to find these common angles. And that works. So alpha, ignore the negative. The negative doesn't belong to the top for sure, top or bottom. But ignore the negative. there should be an angle that cosine equals root 3 over 2 and sine equals 1/2. It's that first angle, 30 degrees. And then the whole thing's going to be negative when sine and cosine have opposite signs. So quadrant 2, sine's positive, cosine's negative. Quadrant 4, sine's negative, cosine's positive. But the other thing about tangent cotangent is they have a period of exactly 180 degrees. So instead of doing 2 quadrants, you could just do the first quadrant plus 180k instead of 2 of them plus 360k. Either way, you'll get the same answer. So the the shortcut is to say quadrant 2 would be 180 minus alpha, 150 plus 180k. And this would give you all the answers. Or you could do 2x equals 150 plus 360k. And then you also have to do quadrant 4, which should be 360 minus alpha, 330 plus 360k. So you could do this or this. This is a lot faster. Divide everything by 2. X equals 75 plus 90k. You got to divide the k part by the 2. So x equals 75 degrees, 1 65 degrees, 2 55 degrees, 3 45 degrees. The 2 inside cuts the period in half, so where we would usually expect to get 2 answers from 0 to 360 with a normal period, normal just x, this divides the period by 2, which doubles the frequency of answers, doubles it from 2 to 4. So you should also kind of know how many answers you expect to get. If you did it this way, I'm not going to do it, you would be a bit more work. You get these two expressions, 75 plus 180k and 165 plus 180k, and you get the same answers. But I like this way better. That's for tangent, cotangent, they appear 180. This one, we're gonna isolate the trig, add root 3, divide by 2. Alpha is, in degrees, this is 0, 1/2, root 2 over 2, root 3 over 2. That further angle, 0, 30, 45, 60 degrees. Quadrants 1 and 2 is where it's positive. 2x equals, quadrant 1 would be 60 plus 360k. And quadrant 2 would be 180 minus alpha, 120 plus 360k. So then you divide by 2, divide by 2. X equals 30 degrees plus 180k. X equals 60 degrees plus 180k. And all the answers, I mean, you don't have to put them in order, but it's kind of nice. 30, 60, 210, 240. 4 answers, which makes sense. We usually get 2 from 0 to 360 for sine, but got doubled because period got cut in half. So that's kind of work I'd be showing. It's kind of work I'm going to also show on 7 and 8, but then we just do a line check afterwards. So we got to move everything to one side when you're solving trig inequalities and equations. There's multiple terms. Factor it. Zero product property says you can set each is equals 0. So this is going to be sine squared x equals positive 1 over 2. Then you got to take a square root of both sides, and you got to do plus or minus. So you're going to get sine x equals, now square root of 1 and 2 is plus or minus square root of 1 over square root of 2 is plus or minus square root of 2 over 2 if you rationalize the denominator, which is probably what you want to do. So plus or minus root 2 over 2. So alpha is 45 degrees, and it's actually all the quadrants because it's plus or minus. And 45 is kind of a unique, if you're doing this, then they're all 90 degrees. It's 45, it's 135, it's 225, it's 315. So we could write one nice general expression for all the answers, 45 plus 90k. Or you could do each one of them plus 360k. It's up to you, but it's a lot quicker. just because 45 is kind of special, equidistant from the other 45-degree angles. 30 and 60 don't do that. So 45, 135, 215, and 225, 315. Check. This is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. So you could have done them separately. Sine equals 0 at 0 plus 180k. There's no alpha, there's no reference angle, there's no quadrants, it's on the edge. So that's going to be 0, 180, 360. Don't forget about 360. Now, none of these bounce off the graph. If sine or cosine equals plus or minus 1, that's when they bounce off the graph. Now, I made a mistake. We should be dealing with radians. Sorry. So it should be 0, 0 radians plus pi k. So this should be 0, pi, 2 pi. I just was in the mode. This is pi over 4 plus pi over 2k. So that's going to give you pi over 4, and that's the same as 2 pi over 4, so 3 pi over 4, 5 pi over 4, and 7 pi over 4. It's easier to not convert these from degrees of radians. That takes way more time, introduces more opportunities for mistakes too. So we got to do a line check, and we're doing 0 to 2 pi. And these are all solid dots, solid dot at 0, solid dot at pi, solid dot at 2 pi, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. They just need to be left or right in the right order. It's the main thing. I'm going to test point. Tell me what you're testing. I love to test 0, but I can't. Pi over 2 seems good though, right? Because sine of pi over 2 is 1. So this would be 2 is greater than 1, or 1 is greater than 0. True. And so pi over 2 is right here, right? Between pi over 4 and 3, that's 2 pi over 4. So there's my true, false, true, false, true, false, true, false. So my answer is, now over here, I'm just counting the 0. So that's going to be curly braces, union, bracket, pi over 4 to 3 pi over 4. Union bracket pi to 5 pi over 4, union bracket 7 pi over 4 to 2 pi. So don't forget about that lone dot. It's not really a lone dot because it's part of an interval, but it's right at the edge of where we're taking answers. Now this one is 0 to 3 pi over 2. So don't just assume it's always 0 to 2 pi. It could be 0 to pi. It could be negative 2 pi to 0. It could be 0 to 3 pi over 2. Now we're going to factor the GCF. It's always a good thing to try first when you're factoring any kind of expression. Okay, so then cosine 2x equals 0, and here cosine 2x equals negative 1/2. So alpha equals, or the negative 1/2, 1 root 3 over 2 root 2 over 2 1/2. So that further angle 0 pi over 6 pi over 4 pi over 3. It's in quadrants 2 and 3. That's where cosine is negative. So cosine equals 0 at pi over 2 plus pi k. And quadrant 2 would be pi minus pi over 3. So 2 pi over 3 plus 2 pi k. And then quadrant 3 would be pi plus alpha. So 4 pi over 3 plus 2 pi k. Okay, so we're going to divide by 2. And we're going to get x equals pi over 4 plus pi over 2k. and x equals pi over 3 plus pi k, and x equals 2 pi over 3 plus pi k. So our roots are going to be pi over 4 plus 2 pi over 4 is 3 pi over 4, 5 pi over 4, and then we're going to stop at 6 pi over 4. 7 pi over 4 is beyond this, okay? And then the next one is going to be pi over 3 plus pi, which would be 4 pi over 3, plus another one would be 7 pi over 3. That's even beyond that. 2 pi over 3, plus, and then 5 pi over 3. Now, I think this one might be too far because this would be the same as 9 pi over 6, and this would be 10 pi over 6. If you want to compare these, give them these common denominators. This is too big. Okay, so line check from 0. Now, these need to go in order. These are solid dots, pi over 4, and then pi over 3, and then 3 pi over 4 is less than 1. And then I think 5 pi over 4, because pi over 4 is smaller than pi over 3. So I think we missed 2 pi over 3. 2 pi over 3, if we get, that'd be 8. This would be 9, so 2 pi over 3 is right there. Give them these common denominators in your head or on paper or whatever. And then 4 pi over 3. And then 3 pi over 2. So I think we're good there. So we're going to test 0, my favorite. Cosine 0 is 1, so it's 2 plus 1 is 3 is less than 0, false. False, true, false, true, false, true, false. So the answer is pi over 4, pi over 3, brackets, union, 2 pi over 3 to 3 pi over 4, brackets, union, 5 pi over 4 to 4 pi over 3. So, gotta be good at trig, basics of it. You gotta be good with radians. Shouldn't have to convert. Okay. If you make mistakes and you're doing degrees and then converting radians, I'm probably gonna have less. Not gonna feel as bad for you when I'm trying to grade. Okay, these graphs. So this is what I want you to write. I want you to draw the axes. X, Y. Mark the period. 2 pi 360. Cut it in half. Cut the halves in half to get the quadrants. Mark your amplitude. So we do this exactly for all these first. And then the sine curve, parent graph 0, 1, 0, -1, 0, y dash line. This is work I want to see. The 3 on the inside divides the period by 3. I want the period in degrees and radians. And the 2 multiplies all the y values by 2. And that's going to be our final graph. So darken it in. Should be a nice smooth graph. We're just graphing one period worth. Emphasize the max, emphasize the min. There you go. That's what I'm looking for. Okay, next one. Two pi, 360. Cut in half, cut the halves in half, get the quadrants. Amplitude, -1 to 1. Now cosine starts here at 1, 0, -1, 0, 1. Y dash line. Okay, the pi divides the period by pi, so it's 2 radians or 360 over pi degrees. Okay, that's taken care of. I don't need to change the period. Next would be 3. So all the y values get multiplied by 3. The negative flips them. So positive 3 goes down here. This goes up here. This goes down here. So now the graph is upside down. And then the 1 moves everything up 1. So it goes up here. This goes up here. This goes up here. This goes up here. This goes up here. Darken it in. Leave the rest. Should be a nice smooth graph. It looks like it'd flow right into another one. I need the max labeled. I need the min labeled. That's what I need. All right. Okay, last one. Period. 2 pi, 360. Cut in half. Cut the halves in half. 1, -1. So sine starts here at 0, 1, 0, -1, 0. Those are the dots I need. Okay, the 3 divides period by 3. The -1, it's just everything down 1. So you're going to do order of operations from the inside out. So that's the new graph. And then the absolute value makes everything that's negative become positive. So that means this graph, essentially the whole graph, usually just parts of the graph get flipped, but this whole graph is all negative. So it all gets flipped. And then the 2 multiplies everything by 2. So this y value is 4, this one's 2, this one's 2, that one's 0. So it should be up here. Final answer, darken it in, need the max, need the min. There you go. That's it. Okay.